Of many great organizations tabling over here. And I encourage you to go over and talk to those organizations and learn about how you might be able to get involved. Time to get started. Climate Science on Tap. Is everybody ready? You guys clearly haven't had enough beer. Let's try that one more time. Welcome to this edition of Climate Science on Tap. All right, thank you so much. This edition, Energy and Climate Policy at the Crossroads. Will the world act on climate change fast enough? My name is Sean McDonald, and I'll be moderating tonight's sessions. Once again, I'd just like to thank Lagunitas and Patagonia for supporting this event. We have a great set of speakers tonight and a fantastic panel. Just to give a shout out to our panelists tonight, we have Nick Turan, nuclear reactor physicist with TerraPower. We've got Reed Schuler, senior climate policy advisor with the governor's office, and Luann Thompson, UW professor of oceanography at the University of Washington. We'll go ahead and get started right away. I'm going to introduce our very first panelists for tonight. The general approach that we'll take is each one of our panelists will have a chance. Listen to that guy. Listen to him. We're going to go ahead and have our three panelists. Each panelist is going to have an opportunity to present on their topic. Then after each panelist has had an opportunity to present, we're going to invite them up here to the stage for a Q&A. So as you're listening to the presentations today, please take a moment to write down your questions. Jot those down. You can either ask those during the Q&A, or you can give your question over to one of our volunteers, and they can pass it along to me, and we can make sure that your questions get answered. So I'd like to go ahead and introduce our first panelist for tonight. Nick Turan is a nuclear reactor physicist and engineering manager at TerraPower, LLC in Bellevue, where he's worked on advanced reactor design since 2009. He got his PhD in nuclear engineering from the University of University of Michigan. Pardon me, sorry, Nick. From the University of Michigan after discovering the field during a search for an impactful climate change-related career. Was that a Google search? You just Google it. It's funny, when I Google nuclear reactor, the FBI show up in my house. He is also the founder, editor, and system administrator of the public education website whatisnuclear.com, which gets roughly 2,000 unique hits per day from curious people and apparently some bots as well. He's married to a resident physician at the University of Washington and is a mentor with Big Brothers Big Sisters of Puget Sound. So let's go ahead and give it up for Nick Turan.
Thanks a lot. Thanks everyone. Thanks for coming. I'm pretty excited for this evening. I'm just going to kick it off with a brief 10-minute history of how humans and energy have interacted for all of history and how we're going to be able to interact in the future. It's a quick 10-minute talk, no problem. To get started, I think we have to talk a little bit about what is energy. I think you all kind of have heard that it's the capacity for doing work. That's a little bit too abstract for me, so I tried some other definitions, like the antithesis of the heat death of the universe. Does that work better? That didn't work too well for me either. But really, I mean, without energy, nothing would move, nothing would have any temperature, it would be horrible. But the working definition for tonight is really going to be this last one, which is a replacement for the labor of human beings. That's not an all-inclusive definition of energy, but that's, humans are inherently lazy, and when we find some energy that we can have do stuff for us, great, we can use it, and that's generally good, right? That's quality of life. So just to make that concrete, I have a couple examples. You can imagine construction with human energy is hard, boring. But today, using energy, you can build South Lake Union by flicking your wrist on this tower crane, and it's just, there you go, buildings pop up everywhere, thanks to energy. Farming, how many of you grow all of your food for you and your family year-round? We got a little bit over there. Not many of us. Because of energy. We used to all do that, and now we have a few people riding around in combines that provide food, more food than has ever been created, because we're riding along with energy. Yay, energy. Laundry. You could spend all day doing this, or you could just throw it in here. If you could get it to fold the laundry, that'd be even better. Figuring, the first human computers can be outpaced by this $30 Raspberry Pi a couple million times over. Again, thanks to energy. How about travel? You want to go to Seattle from St. Louis? That's 6 months on the Oregon Trail, and you're all going to get dysentery. Or you could hop a quick trip to DC for lunch. Mount Rainier there. Thanks, Alaska Airlines. So anyway, you can really see heating. You want to chop wood or press a button. Water, huge deal, and that still is happening in the world today. And all sorts of other things. Energy really helps us do an incredible amount of things that give us our quality of life. And indeed, if you plot energy usage per capita as a function of quality of life, it looks like this. This is the Human Development Index, which is a rough correlation with quality of life. It's hard to quantify. And this is how much electricity use per capita these different countries use. You can see United States up here, and you can see China and India and Pakistan down here. They want to come up here. More energy is replacing their labor, and so they'd like to use more energy and get better quality of life. Great. No problem, right? You all know where this is going. So what fuels have we used to replace human labor throughout history? Well, in the United States, it looks kind of like this. We started with just water wheels and fire and humans and animals, and that worked great for a long time. And then, thank goodness, in the 1800s, coal came along. And I know what you're thinking, thank goodness. But actually, people were totally deforesting all of North America and Europe to make charcoal to smelt iron. And the forests were in severe danger of being totally wiped out to get charcoal. It takes a lot of wood to make charcoal. And so when coal and coke came along, that saved the forests of Europe. Kind of a tough audience for liking coal. More on that in a second. And then oil came in, and we all got automobiles and replaced our horses with oil, and the natural gas came on and started heating our homes, and now it's actually producing a huge amount of our electricity. And then in the 50s, you can see nuclear came on, and down here, this little green guy is wind and solar with their rapid increase very recently. So that's what we've used so far. And this is just the United States. The rest of the world looks pretty much like this. Okay? So, and a little bit more on how awesome fossil fuels are. Sorry. It really, it's easy to hate on them now, and there's reason to, but it's good to sort of step back and realize that without fossil fuels, you wouldn't have any of this stuff. You wouldn't have the quality of life that we have. 86% of the world is powered by fossil fuels. It's given us a lot of good. All the metals, railroads, global health, moon landing, internet, Chihuly. That stuff runs on, that's a propane torch, I believe. If you want to, this is sort of, I don't really recommend this book, but there's a whole book about how great fossil fuels have been because, when you're heating a winter home with fossil fuels, you're changing a dangerous cold climate that would kill you if you didn't have heating into a safe climate. It's kind of a crazy idea, but anyway, you can read more if you really want to hear about that. So anyway, energy is good even if it comes from fossil fuel, but there's a problem. Fossil fuels produce greenhouse gas, and we now know that this is super dangerous, and there's climate change, and I think everybody in this room probably agrees that there's climate change. And the big gray chunk here is the fraction of world greenhouse gas that's produced because of fossil fuel, making energy. Okay? This green one here is agriculture, so that's a big chunk. That's the cow farts and stuff. But you can see that this massive chunk of it is just from energy. So that's kind of what I'm focusing on now for today. So anyway, greenhouse gas problem. So how do we get high quality of life without greenhouse gases? Simple question, right? And here's a simple answer. There are low carbon energy sources, and I'm sorry that you probably can't read this at the bottom. This is in order. This is the grams of CO2 equivalent produced per kilowatt hour of electricity generated. This is from the IPCC, you know, the UN Organization of Climate Scientists. So you can believe it. Coal is no good. Biomass with co-firing, no good. Natural gas, no good, but a little bit better. Biomass dedicated, twice as good. And so I'd say you could probably draw the line right about there where solar photovoltaic comes in. That's pretty low carbon. That's legit. And then you have geothermal, concentrated solar hydro, tidal nuclear, and wind coming in for the most, or the least carbon intensive energy sources per kilowatt hour. Go nuclear. No one? One thing to note here is this sort of error bar on hydropower, which is super interesting. And it turns out that people have known about this, but it's getting more studied. It's not very well known, but if you have a very large reservoir, particularly in a tropic area, you get a huge amount of biogenic methane from that reservoir. And in some cases, this is real, in some cases that reservoir will produce more greenhouse gas than a coal plant for the same amount of power. It blew my mind, but I looked into it and it's actually true. I can give you references, it's super interesting. So anyway, but most hydro plants are fine, they're really low. If you just put a turbine in a river and don't have a big reservoir, that's great. Some big reservoirs are okay for certain reasons. It depends how deep it is or shallow or how new it is. The point is that it's very nuanced. So if you just want to build a bunch of hydro, make sure you check it out on a case-by-case basis, because this is really important, because hydro is a big effect, or a big component of a lot of people's clean energy solution. Anyway, so these are our options. What do you guys want to do? I already know. You want wind and you want solar. They are extraordinarily popular with like 90% acceptance rate. They have tons of political support. There is wide tax credits. Everybody loves them and nobody doesn't love them. It's like incredible. You don't like offshore drilling. You don't like nuclear power plants. You don't like fracking and you don't like coal mining. I would poll you, but I think this is pretty representative. And this is great. The tax credits for these renewables, solar and wind, have been totally successful. The prices of generating from these sources has gone down astoundingly. It's been, and that's exactly what the tax credits are supposed to do. So it's actually been awesome, and the wind and solar is ramping up as expected. So that's great news. Here's what's expected to happen. So this is world energy consumption, a projection out to 2040. Now, one thing about projections, is that they're all wrong, but this is one from our Energy Information Administration, and it shows that renewables are going up at a really respectable rate. Natural gas is going up right with them. Coal and oil are holding steady and going up a little bit. Nuclear holds steady. Not acceptable. This doesn't decarbonize at all. So if this business as usual plan, which is what it looks like we're doing, is going to happen, we haven't succeeded in decarbonizing at all. So we need pretty dramatic changes to the current business as usual worldwide to do any better. Intermittency in wind and solar is actually a serious challenge. And this is where I get controversial, sorry. Wind and solar are on less than 30% of the time. It's dark sometimes and it's not windy sometimes. Like if you go outside right now, it's both of those things. In California, when the sun goes down, 13 gigawatts of natural gas has to fire up in 3 hours. That's a big challenge and it has limits. Oh, you can just put batteries in there. Elon Musk is doing batteries. Yes, you can. It is not impossible. It is a challenge though. Imagine a football field 6 meters high, that's like 18 feet. Those lithium-ion batteries are going to cost you $4 billion and you have to rebuild them every 20 years. That's for a single power plant. You need about 600 of those in the United States to get through one night. What if there are 2 cloudy nights in a row? Or worse, what if there's seasonal intermittency, which there absolutely is? The sun is a factor of 4 less intense in January than it is in July. You can't store your energy in batteries from July and bring it out in the summer, or sorry, in the winter. What if you have multiple cloudy days in a row? Yeah, you could build a battery bank that big, but it would be extraordinarily large and it would have a footprint way bigger than the problem you're trying to solve. So anyway, it's a challenge. It can be done. There are things that can help about it. You can do pumped hydro, where you actually take the excess energy during the day and pump water up into the dam, into the reservoir. Remember that error bar though, and then let it come back down at night. That's an okay option, but you have to be careful with it because of what I mentioned earlier. So anyway, quick plug for my favorite energy source, nuclear power. So I'm a nuclear engineer, as you may have heard. I got into it because I thought its extreme energy density could help with climate change. You can get all of your energy for your entire life in one soda can, and that makes one soda can of waste. It's not nice waste, but it's a soda can of waste. James Hansen, the climate pioneer, is very pro-nuclear and has published a paper with NASA that says the nukes have prevented 2 million lives net. If you take all the deaths from accidents and all the lives saved by displacing air pollution deaths, it has saved 2 million lives, and it's definitely offset 65 billion tons of carbon dioxide. It's 24/7, so not intermittent, and it produces, right now, 60% of the carbon-free electricity in this country. So it's our climate champion. Go nuclear! Come on, guys. It's a known tech. We can expand it. You can't expand hydro very well, but we can build a lot of nukes. There is a legitimate problem with cost. Westinghouse just went bankrupt because of botched builds in the South. So the industry better figure out how to build them cheap if it wants to actually be relevant. But we know it can be cheap because South Korea right now is building them cheap. And in the 70s, France they electrified their whole grid with nukes, and it was cheap. And the way both of those people did it is by standardizing. They chose a design, and they built it again and again and again without changing it. And if you do that, you can make it cheap. Plus, there's a bunch of advanced reactors, like the stuff Bill Gates is paying me and some other people in the audience to work on that have really awesome capabilities. So anyway, if you want to discuss that later, we'll do it in the Q&A. And last point is that if you think we can just reduce the amount of energy we're using, maybe we can. But there's stuff like Bitcoin coming online. This is a pretty modern example. You've heard of this. Bitcoin, right now, the network could power 3 million homes. That's how much electricity Bitcoin is using. All it's doing, when you mine Bitcoin, you actually take these huge warehouses of computers and you solve stupid math problems, like hard math problems that only a computer can solve, and that gives you a Bitcoin. And there's currently 3 million homes of this electricity going on. It's kind of nuts. So anyway, you just have to be careful. This kind of thing can really affect our climate future. If we're increasing energy like this, we better have a lot of very clean energy, or else we're going to be in trouble. And so the way I see it, we need everything on the right-hand side of my clean energy graph. Everything we got, we need it as fast as we can. And that's humans and energy. Thank you. And if you're a real wonk, you want a book on this, you can read this and it'll tell you everything, more than you ever wanted to know on this particular topic. Thanks.
Yeah, thank you very much, Nick. Let's give it up for Nick one more time. Thank you. All right. It's my pleasure now to introduce our next panelist. Reed Schuler is a senior policy advisor for climate and sustainability to Governor Inslee. He served previously at the State Department as a U.S. negotiator for the Paris Climate Agreement, and then on Secretary of State Kerry's policy planning staff. As a negotiator, he managed the U.S. diplomatic effort to galvanize all countries in the world to submit ambitious climate action targets and led the U.S. technical group to analyze these targets. Reed has conducted research in urban development, transportation, and sustainability as a Fulbright Fellow. He is a recipient of the Switzer Fellowship for Environmental Leadership and a graduate of Pomona College and Yale Law School. Reed lives in South Seattle with his wife Ashley and a little baby named Nico. I think, is Nico your roommate? No. Yeah, sort of. A very young roommate. Anyway, let's go ahead and give it up for Reed Schuler.
So I'm a state official, so I think I'm not really supposed to talk much about electoral politics right now, but I think Doug Jones is winning in Alabama. So just reporting on that. I'm not saying anything about my preference, but you all might have views on that. I don't know. Totally neutral. So yesterday, I talked a little bit about climate change in front of another group, and I normally say, please feel free to interrupt me at any point with questions or comments. When I said that last night at a retirement home, there were audible groans from some people who I think knew what was coming, and I got some fairly confusing questions in the middle. So I'm gonna start a new trend and not do that right now, but we'll have plenty of time for hard questions later. So I'm happy to do that. Anyway, so I hope most of you are just floating through this talk on the wave of good news about Doug Jones, and I can pretty much say whatever. So I'm going to talk to you about a few things. I'm going to give you a brief history of the international negotiations on climate change. It sounds a little silly to do that in 5 minutes, but you just got a history of energy consumption over world history in about 5 minutes, so that makes my task feel less ridiculous. And I'm going to talk about what the election of Donald Trump meant for the international climate scene. The preview of that is it was bad. And then I'm going to talk a little bit about Washington State and my boss, Governor Inslee, and what we're up to. So to start off, the first phase of the kind of international discussions for tackling the global challenge of climate change came about basically in 1992. And the nations of the world spent a few years talking in their very slow-paced, deliberative way, and they came out with what's called the UN Framework Convention on Climate Change, or the UNFCCC for people who don't like saying all those words. And this convention was actually submitted to the Senate by none other than George H.W. Bush in 1992. And George H.W. Bush said then, "I am confident the United States will continue to lead the world in taking economically sensible actions to reduce the threat of climate change." So we can take a few things from that. One, George H.W. Bush was overconfident about federal leadership in the U.S. on climate change. Two, we've come very far and very negatively in terms of the political divide on climate change. It's amazing to think not only that a Republican president submitted this UN treaty on climate change to the Senate for ratification, but the Senate achieved the 2/3 requirement to ratify that treaty. And not only did it achieve the 2/3, but it was unanimous. There was not a single senator in the United States Senate in 1992 that voted against that treaty. So that's tragic to think about where we were then and where we are now. On the other hand, that treaty was not one that required a lot of action. It basically said a few things. It said, climate change is important, we all need to work at it, and let's keep talking. So that's an easy thing to sign up to. And indeed, the world kept talking. They met every year to talk about new add-on portions of the treaty. The next big step was Kyoto Protocol, and I do not have time to go into that. But then the next big phase of those negotiations came in the lead up to 2015, the Paris Agreement. So the Paris Agreement represented the first big, serious level of global action since the early 90s. So in basically 20 years, the world talked a lot and did nothing, and that's represented in carbon dioxide concentration charts that many of you have seen. And I have no slides because I'm lazy, but trust me, if you haven't seen it, carbon dioxide emissions have been rising. And the international negotiations were really falling apart based on two questions. And those two questions were, what countries need to take action to reduce emissions, and how do we decide how much action they need to take? And developing countries said 100% of the action needs to come from developed countries, and we will collectively specify exactly how much they need to do. And for a variety of mostly political reasons, that was unacceptable, unsurprisingly, to the developed countries of the world. And increasingly, that became a not very appealing solution when, in fact, the majority of the world's emissions today are from developing countries. Of course, they've been developing later, they have less historical contributions, but they're a significant part of the problem now, so any solution that was only going to come from less than half of the world's emissions was not going to cut it. So the Paris Agreement had, I would say, a breakthrough mechanism for dealing with the problem, and this mechanism is both the greatest strength of the Paris Agreement and it's also its greatest weakness. And I think most of the people involved with it and following it agree about this. And that is the Paris Agreement calls for every country in the world to participate, and to participate by developing its own target to reduce greenhouse gas emissions. So each country gets to come forward and say, here's what I'm willing to do, and if you don't like it, shame me for it, basically. It tries to create a political platform where all the countries of the world can scrutinize each other's action and say, you know, that's not enough, or that's a strong target, but you didn't achieve it, and it's basically a system of peer accountability. Now, I don't know whether that sounds strong enough to all of you to solve the problem of climate change. It doesn't to me, and I don't think it is, but as Winston Churchill said about democracy, the worst form of government except for all the others, I think that applies to the Paris Agreement on climate change. It's the best thing we've got right now, and I think the next speaker, Luann, is going to show you a little bit about the impact that these targets have collectively made on the trajectory of global emissions. And the answer is that it made a significant impact, and in particular, if you look at the later term impact of these steeply growing emissions, the targets that we have right now basically blunted some of the end of that impact. They reduced the tail end. So these most extreme predictions that you used to see about where emissions might be in 2100, those have changed significantly. So we need to see a lot more action. And the Paris Agreement calls for 5-year cycles of countries coming back and saying, okay, here's my new target, here's my update. So there's a lot of work ahead of us. This story is just now continuing to be written. But the Paris Agreement was a big step forward in that it was the first big set of consensus among all the countries in the world to move forward. And so the Paris Agreement in 2016, I think most people thought it was negotiated, it's done, everyone's a part of it. What people forget about the horrible and banal world of treaty negotiation is that you're just kicking off another process of countries ratifying these agreements. And that can take years and years and years and years. Amazingly, the Paris Agreement had sufficient global political consensus that enough countries joined the agreement to bring it into force within just 1 year. That's basically unprecedented. I'm not sure that's ever happened, and if it has, it was something that didn't matter, trust me. I haven't looked it up, but I think that's true. And so that was an extraordinary level of political consensus around the world that we needed to take action and that we had a basic way of doing it. And then, almost immediately after that happened, Trump was elected president of the United States. The world was not quite sure how to absorb that news on many levels, but climate change was a particularly worrying one, to say the least. When the election happened, I was at the annual climate talks that were in Morocco that year, watching the election returns with a group of other American climate change negotiators. And that was a room full of tears there, as I'm sure it was here in Seattle. And our international colleagues from around the world were absolutely stunned. The Obama administration had spent 8 years slowly rebuilding the credibility that was lost during the George W. Bush years and saying, you know, sorry about that, but it was basically a hiccup on the national stage, and we're back, and climate leadership is here to stay. And then we had the election. So that was a pretty profound loss of American credibility in the international climate arena at a time that we could ill afford to have it. In the lead up to this year's climate talks, what we like to say was there are only 2 countries in the world besides the United States that have not indicated that they want to be part of the Paris Agreement. And those 2 countries are Syria and Nicaragua. And Syria is in the middle of a catastrophic civil war, and it's run by a bloodthirsty dictator, so, you know, not a great peer group. Nicaragua had actually said the Paris Agreement didn't go far enough, which is hard to disagree with. So it was minimal company there. And both of those countries actually decided that they didn't like being used as a talking point. And in the wake of President Trump's announcement that he wanted to withdraw from the Paris Agreement, they actually both signed the Paris Agreement. So we're alone now. We no longer get to hide behind Syria and Nicaragua, those 2 global leaders on this issue. And now it's only the United States in all the world, of all the 193 parties to the United Nations, we are the only one in the world that have said we don't want to be part of the Paris Agreement. And that's a tragic thing. My boss, Governor Inslee, in the immediate aftermath of that announcement, formed the US Climate Alliance, which is a coalition of now 15 governors. It's co-chaired by Governor Inslee, Governor Cuomo of New York, and Governor Brown of California. And it's a bipartisan coalition. There are only 2 Republican governors, but there are 2. And that's a coalition of states dedicated to fighting for the goals of the Paris Agreement, dedicated to saying, despite what's happening at the national level, we're still going to see this thing through. We're going to work to achieve the US target on greenhouse gas emissions. We're going to work in our own states and between states to achieve these things. And that's a group that's now talking directly to the rest of the world. So we just came back from the climate talks in Germany, where Governor Inslee and other governors met directly with the heads of other national delegations and basically said, you still have a partner in the United States on climate change action. It's just not at the federal level anymore. It's governors, it's mayors, it's faith groups, it's activists, it's businesses. It's just not the feds. And that's a tragic and unfortunate thing, but there are so many people, many of them here in this room, working on picking up the pieces. And so there's a lot that can still be done. It doesn't fully make up for what's happening at the national level, but now is the time to work as hard as we possibly can to manage the impacts, take things forward, ignore the federal government where we can. I never thought I'd be saying that, and taking things into our own hands. And there's a lot that we can do, and there's a lot that needs to be done. So let's keep working on it. Thanks.
All right, thank you very much, Reed. That was great. So at this point, we've learned from Nick how we got to this place, and we've learned from Reed about these negotiations and the development of climate policy. And now, because this is climate science on tap, we're going to learn now about the ramifications of all of these actions for the climate. So my pleasure to introduce our next speaker, Luann Thompson. She's the Walters Professor of Oceanography at the University of Washington. She obtained her PhD in oceanography from the Massachusetts Institute of Technology and the Woods Hole Oceanographic Institution. She's a physical climate scientist who uses observations and climate models to investigate the role that the ocean plays in climate variability and change, and is a member of the NASA Ocean Surface Topography Science Team. So clearly her resume is much better than mine. To get her mind off of climate change, because everybody needs to do that every once in a while, she loves to play with fiber and read mysteries, and is married to another climate scientist, so she just can't get enough of this stuff. And is the parent of an almost 21-year-old daughter who grew up listening to discussions about fluid dynamics and climate change around the dinner table, which is better than my daughter who just hears about American Idol. So with that, let's go ahead and give it up for Luann Thompson.
So I have to say that my daughter is actually in the audience today, and by chance she's not majoring in oceanography or geology, she's actually majoring in philosophy. But I think we need people who think deeply about the quandaries that we're in, so I'm actually really happy she's doing that. I don't know if I've ever told you that. So what I wanted to talk to you today about is carbon emissions, carbon dioxide concentrations, and warming, and just thinking about where we need to go into the future to reach some of the, to sort of keep our climate in a habitable and pleasant place that I think all of us want to do. So to start off, I just want to give you the take-home messages before I forget. That the Paris Agreement is really an important first step, as Reed said, but future emissions of carbon dioxide reductions are necessary. And the other thing that I want you to take away, that it's really important to not wait to cut carbon dioxide and other greenhouse gas emissions because they accumulate in the atmosphere. So the longer we wait, the worse it's going to be. And then the final thing is that a peak temperature gain of 1.5 degrees C is actually better than a peak temperature gain of 2 degrees C. And every ½ degree C increment will give us a worse climate. Okay, so I'm going to give you, since I am a professor, I'm going to make this sort of, pedantic, but hopefully that will be helpful. So first of all, when I define emissions, what I mean is input of carbon dioxide to the atmosphere from human activities, and the units are in petagrams of carbon per year. So it's a rate that we're putting carbon dioxide or carbon into the atmosphere. And then there's also the time of peak emissions, the time of the maximum yearly emissions, and we'll see that we really need to start reducing emissions as soon as we can, so there's a time where we're actually going to turn the corner. And then the nationally determined contributions are the actions that each country will undertake for the Paris Agreement, and Reed talked about that as well. And here will be the emission targets for the 2020 to 2025 timeframe. And then negative emissions are actually removal of carbon from the atmosphere through things that we do, whether it's replanting forests or some sort of carbon capture and storage. So how much is a petagram of carbon? It's about 10 to the 15th grams. And so I actually looked this up, and there was a nice table that told me how much that was. So a petagram is about half the mass of the Rock of Gibraltar, or about 78 Grand Coulee dams. And right now we are emitting about 9 petagrams of carbon a year, or about 4.5 Rock of Gibraltar. So hopefully that'll help you remember that. So what about the Paris Climate Agreement? What does that have to do with the climate science? So the long-term temperature goal under the Paris Climate Agreement actually became explicit, unlike the earlier agreements, and that is to hold the increase from 1850 in the global average temperature to well below 2 degrees C, pursuing a target of 1.5 degrees C by 2100. And that in the long term, the peak emissions should occur as soon as possible with zero net or negative emissions by the second half of the century. And then the future global commitments are these new nationally determined contributions that are going to happen every 5 years. So there's going to be a constant reevaluation of those, what everyone has agreed to in terms of their emissions. Okay, so now concentration. So concentration of carbon dioxide is currently 405 parts per million. I hope I have the most recent number. And the pre-industrial concentrations were about 280 parts per million. So it's helpful for me to think of this visually. So all those dots are other molecules that are in our atmosphere, and the red dots are carbon dioxide. So it's actually a very small percentage of the atmosphere. And 405 parts per million is about the same as 800 petagrams of carbon. And if you add 2 petagrams of carbon, you actually raise the carbon dioxide concentration by 1 part per million. Okay, so what is going on right now? This is a budget over about 10 years. And right now, the sources for carbon are the fossil fuel burning, which you can see there in the orange bar. And then there's also a source from land use change. So if you cut down trees, you're actually emitting carbon into the atmosphere. And then there's 2 really important sinks. One is in the land. When you grow plants through photosynthesis, you actually fix carbon. And then the ocean actually takes up quite a bit of carbon as well. And those of you who are worried about ocean acidification, that's related to ocean acidification. And so if you look at the net, so you take those positives and you subtract the negatives, then you actually have the atmospheric growth in petagrams of carbon per year. So that's what's going into the atmosphere and staying in the atmosphere, and every year you add on to that. Okay, so if we think about, this is sort of a very optimistic scenario that I plotted up here. So if we think about the emissions and then the actual carbon dioxide concentration, that 350 parts per million or 405 parts per million or 280 parts per million. So you can see that the peak emissions in this particular scenario is in about 2020, and then you get to negative emissions at about 2080. The concentration you can see is a much smoother picture, and the peak concentration happens actually much later than the peak emissions, because you're still, even though you're lowering the emissions, you're still adding more into the atmosphere, and the concentration will not go down until the emissions are smaller than the land and ocean sink. So that's the other thing to think about. It really is a hard thing to turn around. So does it really matter when we stop emitting so much or when we turn that corner? And these are 3 scenarios from a recent paper in 2016. And there's sort of 3 different plans for the future. And once again, this is a fairly optimistic scenario for the future. So we can reduce emissions starting in 2020 and then have a sort of a constant sink much later. And that's the light blue line here. We can wait to reduce emissions until 2030, and then we come down here, and then we'll have to actually go a pretty big negative emission down here. Or you reduce emissions starting in 2020, and then you have sort of a bigger sink later on. So what does that mean in terms of temperature? So from emissions, we go to concentration, and then the concentration determines the amount of warming that the climate system has. And so you can see that under the pink scenario, we actually get the peak temperature well after the peak emissions. And then we sort of level out here at a certain level for the blue. And then if we look at this darker blue emissions curve, it actually starts to go down in the future. And you get a peak warming here of 1.8 degrees C. It's actually not at the end of the century. It peaks mid-century and then goes down. Here it's 1.5 degrees here, and it's 1.3 degrees C here in 2100. Now the slow temperature response is partly from the buildup of the carbon dioxide. As I showed you, you get the sort of smooth buildup in the atmosphere, and partly from how long it takes to warm the ocean, and that's another talk for another day. Okay, so where did the Paris Agreement get us? And I like these three scenarios as sort of thinking optimistically where we want to get. So the current NDCs, these national determined contributions, are about here. So we're kind of on this magenta path here. And there's about a ½ degree difference between this magenta path and then the light blue path down here. So we'd really like to be on this light blue path to get to the 1.5 degrees C warming by the end of the century. But to do that, we're going to have to rapidly decrease our emissions. So let's see what the difference it would make to have, sort of reach this almost 2 degrees C here and almost 1.5 degrees C here. Okay, so the question we want to ask is, does it make any difference if we warm to 2 degrees C or 1.5 degrees C? And keeping in mind that we have already warmed about 0.8 degrees C since 1850. So we're going to ask the question, or I would say that Schlosser et al. Recently asked this question: a climate that is 1.2 degrees C warmer than today versus a climate that is 0.7 degrees C warmer today. How much of a difference does that make? And is that something that we have to worry about? So they did a calculation based on past observations, just looking at past climates and looking at differences between climate periods that were warmer or cooler. And they calculated sort of what some of the extremes in climate you would experience and how they would be different. So if we warm to 1.2 degrees C versus 0.8 degrees C, heat waves will be about 2 to 15 days longer. Heat waves would be about 1 to 3 degrees C warmer, and heat extremes will be 0 to 1 degree C warmer. So of course I had to put up the picture of the California fires just to remind ourselves that much of what we experience under climate change is not going to be this slow warming, but rather the extremes that we'll experience through forest fires or other sort of episodic things that really can impact lives. The next one is that if it's 1.2 degrees C warmer than today versus 8.8 degrees C warmer than today, the annual maximum daily rainfall would be 5 to 10% bigger. And of course I put up a picture of Houston. I know that's a tropical cyclone, so it's not really part of this analysis, but it does give the picture that if you really increase the maximum daily rainfall, then your chance for flooding is really going to go up. So I know this is kind of a bummer, isn't it? To talk about really rapidly decreasing our emissions and going negative mid-century, despite all of the bad things that are going to happen in terms of extreme events. But I wanted to give us points of optimism before we finish with the formal presentations. First of all, the Paris Agreement was a huge step forward. It was very aspirational, and it really set the framework for future negotiations. And all of the countries, parties to the UN Framework Convention on Climate Change signed on. I had 197, I might be wrong, Reed is probably right about that. The other thing is that the nationally determined contributions requires that parties put forth their best efforts. And the agreement is designed to strengthen the NDCs with more emissions reductions as we go further, with this every 5-year, what they call stock take, to say, okay, where are you? Where do you need to go? And the other thing is that the U.S. is abiding by a 4-year exit process. So they're not removing right away. It's not an instantaneous thing where we'll just leave the whole negotiation table, but we're abiding by this 4-year exit process, which the date of that is November 4th, the day after the next presidential election. So it's something to think about as we look forward to the future. And I think that's it for me, so.
Great, thank you very much, Luann. So at this time, I'd like to invite our panelists up front. We're going to go ahead and get them some chairs up here on the stage. I have a couple of additional announcements to make. All right, so while we're getting our panelists set up front, I just want to give you one more opportunity to write down any questions you might have for these folks. We have several microphones, obviously this one here. We have another microphone over here in the corner, and I encourage you to come up with your questions and feel free to ask them yourselves. I think because of the acoustics in here, we really do want you to be on a microphone in order for our panelists to hear. While they're getting set up, I do want to... Well, actually, I have an incredibly important announcement to make. The bar is going to close in about 15 minutes, so I would strongly encourage you to get another beer for the Q&A while I'm making a couple of additional announcements. So please, wet your whistle. Again, the proceeds go to benefit Cascadia Climate Action. So while we're getting our panelists set up, I do want to make a plug for Cascadia Climate Action. If you haven't already checked out the website, please do so, cascadiaclimateaction.org. Obviously, we, as part of Cascadia Climate Action, we host these Climate on Tap events, and the website has a lot of really useful information. I want to go ahead and I'm going to give you some of that climate action information in a second, but I also want to announce the trivia winner right now. That's the really important thing that we really want right now. All right, so the winner from the trivia game, this is discounting some disputed answers. The winner is Team Roscoe. Team Roscoe, let's hear it for Team Roscoe. So Team Roscoe had 8 correct answers, and they got the closest to the number of BTUs with 700 quadrillion BTUs. Runner-up was hairy mammals, also with 8 correct answers. So is hairy mammals around? Hairy mammals, great. Thank you, hairy mammals. So you can go ahead and collect your prizes from Mary at the end of the evening. We also want to make an announcement about the raffle. I think right now Mary and Gloria are going to announce the raffle winner.
So the first number is 253090.
Can you read it again?
253090.
Great. Fantastic. And this lucky person wins a Patagonia bag. It's generously donated by Patagonia. What's the second prize? Ooh, a case of IPA from Lagunitas.
The second number is 253003.
All right, and it looks like we have quite a few door prizes that folks can grab, including these lovely posters. All right, so I think at this point, we're going to go ahead and just make a couple of brief announcements about climate actions. Obviously, you've already heard about Cascadia Climate Action, the website. You can check that website out for the climate's events calendar, updates on some of these events, as well as our Client Science on Tap, so please check that out. In terms of actions that you all can take, you've heard from our speakers tonight, some things that you can do for the climate, things that you can find out about on the Cascadia Climate Action website. First, lobbying your elected officials for climate action, including price on carbon emissions and support for clean energy. You can comment on proposed projects such as fuel export terminals, clean energy and climate change mitigation, including letters to editors, environmental impact statements, and public hearings, all of which you can find out about on Cascadia Climate Action's website. And then lastly, you can join groups to plan and act, and quite a few of those groups are represented here at the tables at the far end of the brewery here. So please, I would encourage you to speak with some of those groups. Oh, we've already announced the winners. So I'd like to go ahead and get started on the panel discussion and the Q&A. And so at this point, if you have a question for any of our panelists, the best thing to do is to head to a microphone and we can go ahead and get started.
We're recording tonight, I want to let everybody know, for KBFG radio, which is the new North Seattle radio. It's a low-powered radio station, but you can hear it in Ballard, Fremont, Greenwood, and Phinney Ridge. So do tune in to hear this and some of the former panel discussions that Climate Cascadia has put on. So it's a rich resource of information. Wanted to ask Jay Inslee's representative. Jay has written a book on solar energy. He co-authored a book on solar energy. He certainly understands it, and he's been a great advocate helping us with the solar bills that we passed in the state. But one of the things he first came into office saying he really wanted to make happen was PACE. PACE is a loan program that would allow for every homeowner to take out a loan on their home and then pay it back in small amounts every year as part of their property tax. 33 states allow for this. Our state at this point does not, but he has said he'd fight for that. Can you bring us up to date on what he's been able to do with PACE?
Yeah, great question. I'm sorry to say that I haven't read his book. I've heard him talk about it, so I'm a little delinquent. So yeah, I think PACE is a really promising policy. I think unfortunately it hasn't quite lived up to the promise. I think people a long time ago, 5 or 10 years ago, I think people thought PACE was going to really dramatically accelerate the uptake, and I think a few states have had success with it, but a lot of states it's been quite slow. The governor's still interested in PACE. He actually was referencing it in a conversation with some folks in the last week about looking at it in Washington. So it's not a really active topic right at the moment, but you're right that a ton of states have it. I think there's no good reason that Washington doesn't, so it's certainly something to look at in the future.
Yes, sir.
The uptake on iPhones was slow at first, too. My question is for Nuclear Man over here.
All right.
Why would we be concerned about replacing batteries every 20 years? And the nuclear industry has not solved the problem of what to do with waste for 25,000 years. And you can't get one of your projects insured, and they cost way more than everything else. Why are you trying to make that argument? Who's paying you to do this? Thank you.
Thanks. It's a great question. And that's typical. That is exactly the kind of feeling that a lot of people have towards nuclear. And as somebody who was looking for a climate change action career and finding nuclear, I knew I was going to be kind of up against this. And anyway, that's a challenge I'm happy to go to. So part of your question was cost, and that is a legitimate question that I tried to address briefly in my talk. Cost is very high for construction in the United States and in the West. However, the Koreans are building them extraordinarily cheaply right now, again by standardizing, and the French, when they electrified their whole grid in the 1970s, by standardizing, did it very cheaply. The plants we've been building in the United States have been one-offs, and there have been supply chain issues, design, changes in design as you go along, and all those things cost a ton of money. That's obviously not acceptable, but we know for a fact that we can build nuclear cheaply because the Koreans are currently doing it. The plants in UAE right now are quite cheap, and their levelized cost of electricity is very reasonable, so that's cost. Now, your other question was on nuclear waste, which is a very important question. And my attempt to answer it, I didn't. The fact is, if you had all the nuclear waste that we've produced in this country for the last 60 years, it would fit in a football field about as big as those batteries would be, but a little bit less. It's like 10 feet high or something like that. Now, it's very toxic waste, but we know exactly what to do with it geologically. We can put it into deep crystalline bedrock, just like the Finns did when they just opened up their first high-level waste repository. And they just did it, and we know how to do it. The only problem is that there's political challenges. People don't want it. People are afraid of it. There is a huge amount of culture and, vitriol against nuclear, which I find very interesting because it is a extremely low carbon, fairly effective, super reliable energy source, and it's proven to be safe, even though there have been accidents, but it's like a plane crash. When a plane crashes, you hear about it, but actually plane travel is one of the safest ways to go. It's the same with nuclear. Per gigawatt hour produced, nuclear is one of the safest energy sources, and that is supportable by true facts. So I'm going to leave it at that. Too long of an answer. So.
Great.
Hi, I realize that I don't have anyone to pick from here on the topic that I have. I go to a lot of climate events and that sort of thing. I never hear anyone talk about population control. I never hear anyone say anything about the effects of how many people are here and how it's going to exponentially grow. Do any of you hear anything about talks or anybody trying to make a difference in that?
Louie, you want to take this?
We were asked this question at the last panel that I was on, and I would say that it's going to be a pat answer, but what we need to do is educate women. And by educating women, that will solve a lot of that problem. And I'm passionate about women's issues on many sense, but population control itself, I think, can be achieved through improving the lives of many. So. And, if you look at per capita emissions, U.S. still really leads. So we're the champions in per capita emissions. So something else to keep in mind. Well, educating men is also important, but women and girls.
That's a really good. That's a great point. I was just in a movie star here. But at the film festival in Indianapolis, the Heartland Film Festival, I met a producer who just made a movie. I can't remember what it was called, but it was about educating the men in Africa about about women's rights and women's safety, and it was extremely effective. It was a really awesome story. So, great point.
Fantastic.
Hi, my question's for Reed. First of all, I'd like to thank you for the work that you and the governor are doing on behalf of the state of Washington. But I'm curious about your thoughts on the type of precedent that gets set by a coalition of state governments sort of skirting around the federal government to negotiate directly with other countries, and whether or not that helps our cause in the long run.
Yeah, great question. There's something called the Logan Act that's getting some interest now with the Flynn stuff that criminalizes interfering with federal diplomacy. So we also occasionally are trying to make sure that we're not running afoul of any criminal statutes. That's not quite what you're asking about. I don't think we are. And I think that you want to make sure that you're not in the long run setting a precedent that states in any country can say, don't listen to the head of my country, because that gets messy, to say the least, in international negotiations. So I think that's tough. On the other hand, I think, wherever states are pushing for more action and not less, wherever they're not trying to destabilize the global system, but they're trying to shore it up when they have a dangerous person at the top. And in particular, I think with this issue that is such a high priority, it's such a crisis, I think the need for action, basically justifies states taking the pretty unusual step of stepping up and talking to the international level. But it's an interesting issue, and there are probably some political scientists writing more insightful stuff on what it means and whether it's going to get too messy at the international level for states to be picking up on this stuff. It's also not totally new in that, mayors and governors have been more and more active on the international stage. I would just say it's reached an unusual level of intensity and coordination right now.
So,
thank you so much.
Before you go on, actually, I am really curious about that. I mean, what was that interaction like? I mean, this seems very strange, very awkward, running into each other in the hallways. It's like a sharks and jets situation, or?
Yeah, so you mean what is like the governors running into the Americans working for the federal government there? Yeah, so, there are a couple of camps of Americans who are still at the climate talks. And one of those camps is the civil servants, people like me, who still work for the government and are not having a very good time of it. And those people, weirdly, are right now mostly being allowed to do their jobs in this very quiet way, where you actually have US negotiators still at these talks negotiating the rules of the Paris Agreement, despite the president having said that he'll pull out. So that's weird. The governor did have informal interactions with some of those people and basically said, what's going on? What can you tell me? And they can't say much. I mean, those people are in pretty awkward situations. Then the other camp, besides these poor, non-political civil servants who are hating their lives, the other camp are the political representatives of the White House, and they were at the climate talks too, and they were there to hold an event promoting fossil fuels. Kind of like this presentation, but more intense. And so they had like 1,000 people lined up at the door to watch this event. I would say 950 of those people were there to protest the event, and the other 50 were there just to watch and marvel. So that's an awkward interaction. The way the governor handled it was to push to the front of the line, walk into this event, and hijack the cameras that were all lined up there for the event and say, don't listen to this. This is crazy nonsense. They're just trying to be provocative. And then he left before actually talking to the White House guys. But, I think they're there almost just to flip the finger to the world, because if you want to sell fossil fuels to the world, you don't go to a climate change conference, right? So I think they're just there saying, we don't care about the world, and part of our mission is America first, to say, we can do what we want, we don't have to work with other people, we don't care about the international system, we don't care about the consensus you've built, we're going our own way. And I think that's a dangerous message, but it's one they're working hard on sending.
People in cities like Seattle have typically lower carbon emissions per capita than people living in the suburbs, about half in the United States. But local governments typically limit building and prices go too high for most people to be living in cities, causing them to move to the suburbs and having a higher carbon footprint. Should we be overriding local communities in order to increase density?
That sounds like a popular topic.
I'm going to start, but I'm going to have to pass to you for policy. So I don't have a great answer for you. That's an interesting point, that the buildings in dense areas are much more efficient than buildings in dispersed areas, that's for sure. I mean, you get heat from your neighbor when you're in an apartment, and that ends up being very efficient. One thing to point out is, in terms of buildings, that's definitely true. I have seen some numbers that from travel, people who live in cities tend to travel a lot also. And you can quickly double your carbon emissions by taking a couple quick flights across the country. So that's something you have to be careful of. That's not really answering your question, but just, just random thought. In terms of what should we be doing, I'm going to have to pass it back to Reed.
Yeah, I mean, I think there are tremendous benefits to density, and it comes from transit, it comes from smaller housing, it comes from a ton of efficiencies that are gained by people living closer together. And you raise the provocative and important point that cities, a lot of American cities, are getting too expensive for people to live in. You know, that's reached crisis proportions here. I'm not an expert on affordability questions, and I think figuring out how to combine those two is probably one of the central challenges of our era. When you say, you know, override local decision making, I'm not sure what specific policies you have in mind. I mean, cities are doing a lot to go beyond, you know, in the same way that many states are trying to take climate change policy beyond the federal level, so too are cities. You know, they're trying to go beyond the state level. Everyone's trying to add on and sort of be more aggressive in pursuing the stuff than the next level up. So I think mayors have done quite a bit to use city-specific tools to take us farther. I haven't seen evidence that those specific tools are decreasing affordability, so I'm not sure there's a trade-off there. But if you want to say anything more about what specific things you're contemplating, we can answer that.
Well, for example, if you want to build a new housing development out in rural King County parts, you can get a local city and they'll agree to build 400 suburban houses. That's no problem. But if you want to build a 400-unit apartment building in Seattle in anywhere but just a couple neighborhoods and just a couple locations, you're not allowed to do that. And by preventing these new buildings, these people are moving out in the country instead of moving into the city. And that is and then the rest of their lives, the rest of the existence of that house, somebody will be living there and having double the carbon emissions they could have had. And that is a choice that Seattle's making, that we aren't stopping them because of our local decisions. So should we, and not just Seattle, but us, and we're supposed to be better, so we should be allowing those. Should we force the state, should the state allow people to override local zoning?
Got it. Well, I think the city is working hard on trying to increase density, and I don't think the states should start to override local decision making when it comes to permitting. There are so many issues related to, you know, local transit and services. I think it would get very messy very fast if the state tried to step in and replace that. But I agree that it's an urgent need to increase density in a lot of American cities and other places because that's part of the climate challenge. So maybe that's unsatisfactory.
If we don't override, it's not going to happen.
Well, okay. I mean, very quickly, I will say you can find 100 different areas where you can ask for a level of government to force people to do something, and I think that gets messy pretty fast, and you start interfering with the way that governments do business. But yeah, I'll leave you to keep pushing for that.
All right, let's move on then. So I had a question actually real quickly for Luann. You know, you talked about impacts, and you talked about a variety of impacts that we might see. And I noticed that last week some climate scientists released a paper that showed that maybe we are perhaps underestimating changes, or at least underestimating the amount of warming we might see. And so I guess the question I have for you is, how certain are we about the projections that we're seeing? And additionally, how certain are we about the types of impacts we might expect to see?
Yeah, that's a really good question. There's a lot of areas of uncertainty in the climate projections. I mean, I gave you very simple graphics here, but there's sort of three main sources of uncertainty in what we think is going to happen in the future. One is interannual variability. Like, we're pretty familiar with El Nino here and what that does to our snowpack and the amount of rainfall we have. So there's a lot of year-to-year variability, particularly locally, that can really impact how well we can predict what's going to happen, say, 5 or 10 years into the future. The other is how much we burn. That also gives us a lot of uncertainty. So I was the one that put together that trivia question of what temperature is going to be at the end of the century. It really depends on what we do, right? And then the third one is really what that paper was getting at, is how much each climate model warms for a given amount of greenhouse gases. And there's actually quite a bit of difference among the models. And the one way that those authors looked at it is that they looked at the patterns of change from year to year and said, okay, what looks most like the observations and the patterns of change, and then chose those models that fit those the best, and then used those to project into the future, and then they found that there was more warming. There's other ways you could choose the perfect model, and I think the climate community is sort of struggling with that. A big source of uncertainty is also how much aerosols or smaller particulates that are released into the atmosphere, how much they cool the climate system, and we don't really know that. So there's a lot of areas of uncertainty, but we do know ballpark, and I think we know enough to make decisions.
Well, actually, just to follow up on that then, because you talk about the uncertainty that climate scientists are having, I'm curious if Reed has a response, because obviously that uncertainty translates into the policy actions.
Yeah, it's terrible. You should blame the scientists. We should have less uncertainty. It's crippling. You know, I have been in the position of trying to get information from some of our scientists and communicate them to other policymakers who absolutely refuse to see any uncertainty at all. Like, you could not show them, you know, it might be this, it might be this. They'd be like, ah, what's it going to be? And that's a problem with policymakers, not scientists, because that uncertainty is real and there's no getting around it. But it's tough. I mean, and so what you do is you end up compressing a lot of that uncertainty into central estimates. So things like the 2°C goal, the goal of limiting end-of-century warming. There's nothing magical about 2°C. And like, do you really believe that if there's a model that will tell you the exact number, that it was 2 and it wasn't, you know, 1.96 or 2.05? But the uncertainty is so big that you just need to arrive on some sort of reasonable central conclusions. And we're so far away right now from being on track to meet those targets that you can be sure that we're engaging in too little action, not too much. Whereas if we were perfectly calibrated to hit that, then you might have some questions, you know, up or down, or maybe you'd get there if you were 1.5. So it's a big problem, and I think that opponents of climate action seize on the reasonable uncertainties and try to blow those up into saying those uncertainties are so big, why should anyone take any action at all? And that's not fair, because if you look at the reasonable uncertainty range, that's enough for policymaker action, as Luann said. But yeah, it's hard.
Hi there. So I have a question for Nick. Yeah, okay. So, well, it's kind of a double question. One is, I'm not sure why you chose to highlight a moral case for fossil fuels from Alex Epstein. He's pretty much a fossil fuel industry lobbyist, right? I study the ethics of climate change. His book is the least qualified book to speak about the moral questions around climate change as far as I'm concerned. And then the second question is more about, related to the topic of this, is the speed of reducing emissions reductions, right? And that's really the big thing. How do we reduce emissions as quickly as we can? And the problem with nuclear, as I see it, is that either the traditional nuclear is mostly too costly in a lot of places, right? And then the advanced nuclear reactors of the type that Bill Gates and yourself are trying to develop are maybe 10 years out of the way, right? Whereas what we have now is cheaper, more affordable, quicker to roll out renewable energy with storage that can move much faster, right? So if we're thinking about the real speed that we need to develop our energy, our clean energy at, it seems nuclear is maybe a slower technology to develop. So how do you sort of match up that question and pace?
Yeah, so that's a great question. Woo! You can see the popularity of wind and solar. It's real. So that's actually a really good question, and thank you for that. I will start with the first question about the book. I mean, I haven't read the book. I looked the guy up, and I knew that he was total fossil fuel guy. But there were a few interesting points on the Wikipedia page that I thought that were at least controversial and thought-provoking. And the fact that fossil fuels has provided a huge amount of good and quality of life for the world is incontrovertible. And if you want to read the Vaclav Smil book at the end, that's the one that makes the point. That particular book, you're right, I don't recommend reading it. The guy is not, he's not out to help us. But read Vaclav Smil instead. I just put it there just kind of to get everyone to pay attention a little bit more in case they were falling asleep. Your second question, which is very important, is the speed of deployment of different energy sources. And so my suggestion for the world is to build wind and solar as fast as you can. Do not stop. Build it as fast as you possibly can. Dedicate all your resources that you can afford to wind and solar. That will not be enough to decarbonize. Okay? And right now, because of the intermittency problem, again, wind and solar are only on 30% of the time, you need massive storage infrastructure, and that's where you run into a problem. Right now, yeah, you can build up tons of wind and solar because we can handle the ups and downs with natural gas peakers and hydro plant pump storage. That doesn't go all the way. We are building a huge amount of natural gas because it's so cheap. We're going to start exporting natural gas in bulk to the world, and people are going to buy it like crazy. South Korea is going to buy it, Japan's going to buy it, China is going to buy it, and that is a high carbon fuel. And methane is very high warming. And so if you want to get serious, you better start building every low carbon energy source as fast as you can. And nuclear is a massive, it's currently producing 60% of the carbon-free energy in this country. China's building them like crazy. India's going to start building them, and they're carbon-free. And if you don't build them as fast as you can, you're not, even if you're building wind and solar as fast as you can, you will not decarbonize at the rate that these models are telling us that we need to decarbonize. That's the answer. And there are ways to build them relatively quickly. We aren't doing a good job in this country, but again, the Koreans are doing awesome, and we can learn from them.
You have a question?
I think many of us would agree that climate change is a current threat that's already killing people, and I think it's important to not be too caught up in the details, to not be able to say it's already a huge problem. So I think, being an expert and parsing out all the details is great, but to at least communicate to the public, I think it's really important to say it's already killing us. Look at Southern California. It's not a theoretical thing, it's already happening. That was the number one point. Number 2 point is, I'm glad to hear about the safety of nuclear power. I would love to hear how that's received in Fukushima or Chernobyl or Three Island.
Yeah, I wanted to focus this presentation on going forward from where we are right now, because we can't go backwards. So if we look forward to the end of the century or to mid-century, where do we need to get? And that's what I wanted to focus on here. And you're right, you could talk about, we know that there's been changes in extremes. There's no question about that. We know that the temperature has changed. I totally agree with you. It just was not my focus on this particular presentation, but I take your point.
As for the safety of nuclear, again, I think that's a very important question. It's on the top of a lot of people's mind, and it deserves a good answer. And the answer is, for Fukushima, 0 people died from radiation, precisely 0. And I will give you sources. The sources that I take are UN and World Health Organization sources. The same organizations that say climate change is real. And when people debate those organizations, you say they're climate change deniers and they're anti-science. But when those same organizations come out and say 0 people died from radiation at Fukushima, everyone says, oh, it's obviously, who's paying you? And I find that to be very anti-science. The fact is 0 people died at Fukushima. At Chernobyl, people did die. To be precise, 56 first responders, heroic people, went in there to try to put that fire out, and they died of acute radiation poisoning. After that, enough radiation was released to the surrounding area to cause 4,000 premature cancer deaths over the lives of the people who lived there. 4,000 out of several tens of millions. And these are numbers from very legitimate sources. And so, when James Hansen, the climate scientist who first testified to Congress in 1988 that global climate change is real, when he published the paper that said, if I take all the deaths from Fukushima, Chernobyl, 3 Mile Island, also 0, and compare them with all the lives saved by the fact that nuclear energy is totally emission-free, air pollution-free, and when they build nuclear plants, they don't build a coal plant that does kill people through upper respiratory disease, through air pollution, and that doesn't even consider global warming. It turns out that nuclear fleet has saved 1.8 million lives and displaced 65 billion tons of carbon dioxide. And so I say to you, nuclear is extraordinarily safe, even given the fact that there have been several accidents.
Do you have something else to add? Go ahead. I was just wondering. So we got a question earlier, and I just wanted to touch base on this. So some folks are suggesting that we need to, as a progressive city, take some more significant action in places where we can make a difference. And someone had indicated that maybe we have a need to ban internal combustion engines in the city of Seattle. I don't know if you've heard this before. ICE-free by 2023, I think is the slogan that's used. So obviously this would require substantial changes in our transportation infrastructure. And I'm just kind of curious if anybody on the panel would speak to that.
So, Washington faces a distinctive challenge, which is that we already have a pretty clean way of generating electricity, hydropower. So when you look at our opportunities to reduce emissions, whereas some states have really dirty electricity generating systems such that renewables are a key way of bringing down the emissions, in Washington that's harder, and in particular, transportation is a bigger share of our emissions than in a lot of places. So the shift to electric vehicles in Washington state is going to be really important, and it's a key part of making that transition happen. There are a bunch of countries and some cities around the world that have announced they will ban the internal combustion engine, or they've announced that they have a target to basically phase it out. My understanding is that almost none of those places have real plans to do so, but those are still important symbols of the transition, and I think they're being well received in some places. So I think it's provocative. I think there's about a 0% chance that Seattle has the legal capacity to ban the internal combustion engine. Maybe if they try, it'll still help get some excitement and enthusiasm and generate some momentum for the transition. I think that there's more symbolic power than substantive power in those announcements right now, but that's not saying it's not worthwhile.
If I could chime in, I have a 2004 Subaru. I expect it to last another 10 years. It's an internal combustion engine. One of the best ways to get people to move to clean energy sources is to make it cheap. Make it so that they personally benefit by it being cheap. And so yeah, you could ban internal combustion engines and then subsidize all the low-income people who can't afford to go out and buy an electric car or a new car of any kind. Electric cars may be cheaper than, anyway, but they're not planning on replacing their cars anytime soon. So that's one way to do it. But if you could somehow come up with a way to make electric cars and the very cheap and make people like really benefit from going out and buying that, and try to do it through technical means first and then throw policy on top of it, that would probably be a better way to go. I will say electric cars are great and all, but you have to look at what energy source is charging the battery. So if you have an electric car and you live by a coal plant, you're only helping a little bit because the coal plant is a little bit more efficient than an internal combustion engine. In Seattle, you have a lot of hydroelectricity, so you're probably pretty clean, depending on our reservoirs. But you really need to, so if you buy electric cars, you just need to make sure that you have clean energy charging them.
Thank you. Maybe we have time for one more question before we have to break up, because I think we're already at 8:30.
Oh, this will be a good one. We've talked about James Hansen, and he says we've got to get back to 350 parts per million if we want to have civilization, atmosphere that civilization can live in. So I'd like to know why the Department of Ecology is fighting the lawsuit from the kids who are using James Hansen's targets for getting us back to a livable situation.
So it's a good question, and the father of one of those kids talked to the governor recently at a town hall, and those people are passionate about the same thing, achieving great reductions. I'm not incredibly conversant with the details of that lawsuit, but I think that there are a set of emission goals right now that are statutory goals that the Washington State Legislature has embedded in the law, and then there are much stronger limits that the Department of Ecology has recommended. They've said we should be pursuing a much more aggressive pathway, and the legislature hasn't acted. And so I think it's one thing to say, here is the ideal goal for the world, and I agree, we need much more aggressive action, and it's another to wave your wand and say, this is going to happen. So, the governor is, I would say, obsessed with reducing emissions and constantly dissatisfied with our current efforts. So he's pursuing emission reductions wherever he can, and he's trying to get action to ramp up. So it's not as simple as just saying, here's the world's most ambitious goal, and then assuming everything will fall into place.
But they keep appealing the decision. instead of
Yeah.
saying, oh, I guess the courts are right, we
Yeah.
better follow what the courts are asking.
Yeah. Well, I think that maybe we can go ahead and take that conversation offline. I think at this point, and these are all really excellent questions, but it is 8:30, and because it's 8:30...
10 seconds.
No, because it's 8:30, we need to...
So I talked with Mary, and I really just want to say, Reed, I'd like to have you recommend to the governor to pardon Carlo Voli and Steve Way. They sat on top of the crane constructing the LNG facility for Puget Sound Energy, a for-profit Australian company who is they can only be charged with malicious mischief, one, a felony, because it's classified as a public utility. That's a for-profit company, public utility, causing these men to go to jail for a felony.
Okay. All right, thank you very much. All right, so at this point, I'd really just like to thank our panelists once more for coming up here and sharing with us. Nick, Luann, Reed. At this point, if you have any additional questions for our panelists, I'm sure that they'll stick around and they'd be happy to answer those as long as they're friendly and something that you could have over a beer. I just want to once again just acknowledge Cascadia Climate Action and their contribution to this event. So let's go ahead and give Mary and the volunteers a big round of applause. And then also just one more thing, you know, in terms of the groups that are tabled over here, Sierra Club, Audubon, 350.org, and the Fission folks, I think that it would be great if you went over and talked to them about ways that you might be able to take action to help address some of these climate issues that we've been talking about today. So with that, I just want to once again thank you all for coming, and also encourage you all to bust your tables and bring your glasses up to the bar. That'll really save us in the long run. So please have a great night. Thank you very much for coming.